Okay. Yeah, I'm doing good. Thank you. How about you? I see the counts are getting lowered every class by class. Uh, might be since we are almost coming to an end of this batch. So, or might be they are busy with their office work because I heard a lot of offices are being opened up after the lockdown, right? So, and I see sometimes student join after few minutes as well. So when I usually end the class, there will be a lot of guys joined in. So I guess people will join after few minutes. Fine. So let me just recap what we were doing. Okay. So in my previous class, okay. So in my previous class, we were discussing IPSec site to site. Okay. So we have completed with theoretical topic. Lab we had done, but we were not able to execute, or we were not able to do the validation. Okay. So what I do is, first I'll start with this lab. Okay. I'll cover up this lab on my CCNP topology itself. If you remember, I showed you this lab on some other topology previously, but then I got some queries from one or two students that they don't have this topology, and they requested if I could recreate the same site to site VPN on our CCNP topology itself on the GNS. Okay, so keeping that point into consideration, I'll rebuild, or I will recreate the VPN site to site over on our topology itself. Okay, so let me tell you where I'm trying to do this. So if we go towards our lab diagram or our lab topology, so this was the block which was designed for learning VPNs, right? So we are going with IPSec VPN. Okay, once we are done with IPSec VPN, I have GRE also for the day, because IPSec is something which we covered in the previous class, and today is just the small portion of the IPSec left over. Okay, so I just don't want to waste 2 days for just one simple topic, so we will also cover up something called as GRE tunnel. It's again very simple when compared to IPSec. GRE is very simple. So what did we learn in IPSec? If we just recap, what did we learn in IPSec? So we know that this is a part of VPN. This is very popular nowadays. After the lockdown, you might have seen a lot of guys getting involved in VPN troubleshooting, VPN creation, right? So those guys who are working from home, and they're making use of the corporate network, or to connect a corporate network to browse internet, or to connect to the server, that is not site to site VPN. That is called as remote access VPN. Okay, so when I was talking about VPN types, I told you one is called as site to site VPN, which is used for connecting to data centers, to campus, to branch office. Okay, from one region to other region. There was something called as SSL. So this is something which we use uh, for work from home kind of VPNs, where let's say this is my office XYZ, and this is my home. Okay, let's say I cannot travel towards my office, so I'm just using those VPN tokens. Okay, I will have something called as any connect tool. I just open any connect tool, I put the IP address of my firewall, and I try to make a or establish a VPN connection. These are all part of remote access VPN. Okay, so this is a different flavor of VPN, which is not a part of enterprise topic. So under enterprise topic, we have IPsec site to site VPN, we have GRE, and we have DM VPN from lab point of view, whereas MPLS is just theoretical, is what that's mentioned in your enterprise, because MPLS is a service provider topic. Okay, so from enterprise point of view, just you need to know what happens in MPLS and what are the different protocols we use in MPLS. So just a overview. Okay, fine. So under IPSec, what did we cover now? So under IPSec, we know that it's consisting of two phase 1 and phase 2. Phase 1 is nothing but ICKMP. Okay, so we also call it as IKE version 1. This is an older name, ICKMP. This is something which you use nowadays, IKE version 1. Whereas phase 2 is IPSec. Okay, so once, let's say this is one of my enterprise and I have one more enterprise here. In between I have my service provider, right? So what I do is, it's a shared infrastructure. There could be hundreds of other companies who have their tunnel. Might be there are a lot of home users who is trying to use internet for the normal browsing, YouTube, right? So you never know who is trying to hack your packet. So we establish a secure tunnel now. Okay, so we keep our firewall, let's say ASA firewall, or router is also good enough. I told you it's a multi vendor technology. Okay, so let's say I have a Cisco routers on both the side. I set up some configuration here, and over here the configuration should match. Okay, so once we do the configuration, I have to initiate some packet, my interesting packet. These are called as interesting packet. Okay, that's very important, because I might have 10,000 different users with thousands of network. I don't need all my thousands of network to travel over here. The rest of people, they can just take the normal internet. I am just securing those packet which is interesting traffic from my company point of view. It could be launching of a software. Okay, it could be some critical servers which I cannot afford uh, communicating over on ISP. So I'm building this IPSec tunnels. Okay, so these are my interesting traffic. The moment the first packet hits this, there are some access lists that we create. Okay, as soon as this contains the one of the matching parameter of access list will initiate the process. So first ICKMP process will initiate, that is this phase. Okay, negotiation will happen. So it consists of 6 messages totally. So you know how those 6 messages are being negotiated. So first messages will be taken, which carries like 3 parameter. You will receive a response back, which is message number 2. Once they match, once they are good, the third message will be sent, and you receive a fourth message. Now this will be checked. If all is fine, the final message will be sent. Okay, so totally 5 and 6. So totally 6 messages in the case of phase 1. And similar way, once phase 1 comes up, we can write some command to see if we are good or not. So show crypto ICKMP detail will show me if my phase 1 has come up or not. Okay, so let's say phase 1 is up instantly, very instant, automatically. Now it will go towards phase 2 for negotiation, and phase 2 consists of 3 messages. Okay, so it doesn't need 6 messages, it just need only 3 messages. So 3 messages will be sent, and that's all, and your VPN tunnel, it will be built. So let's say this is a tunnel which is forming. So the outer layer is let's say the phase 1 layer. Okay, and let's say this is the phase 2 layer. So once these two phases are built, then the interesting traffic will start moving over on this tunnel, even though it's built over on internet. Okay, so that's the concept that we learned in the previous class, and we are left with the uh, lab. So let me power on these two boxes. So this weekend you can also try creating it over on this, which is left for you guys to practice. So in the class today, I'll set up a IPSec tunnel between these two sites. So this is a Japan site, and this is a Australia site. Okay, and you guys can try to recreate the same thing over on another site, which is a China site. Okay, so between Japan and China, it's your assignment which you will try to recreate, and you will see the different parameters. So let's open the two devices. So I have Japan R51, or sorry, Japan R15. So let's give it some host name. So let's say it's Japan R15. Am I good with the audio? Is there any issue with the audio? I hope there is no disturbance with the audio, right? So let's give a host name here. Let's say it's a Australia R16. Okay, so two sites with me, Japan and Australia, and let's say let's talk about the configuration plan. Okay, let me keep it next to next. Okay, so first point or first thing would be configurations of the phase 1 properties. Okay, so let's see if I have all my required IP address, or it would be good if I can reload these boxes. Yeah, so better would be reload, because there are some IPs and all those things. So let me reload this so that we can do a fresh copy of configurations. Oops, I by mistakenly saved the configuration. I should not have saved it. Okay, now I have to erase this configuration, or might be I will better delete this instance, which is simplest option. Okay, let's start this. Okay, before starting, let's make it as Japan R15, and let's start this. Let's take the console. So let's give some IPs to these boxes. Okay, so let's say this is 12.1.1/24, or let's say .1. That's more than enough. And over here we have it as 1.2. Okay, we can also keep this in 1.3 series. So we have all the IP address on this public interface. Okay, fine. So let this device come up. Let's go and quickly configure the interface IP E0/0 IP address 12.1.1.255.255.255.0, no shut. Okay, and let me save this particular configuration, which is just a default configuration. Okay, just with interface. Otherwise, every time I have to go and keep doing the interface configuration. So keep always interface configuration, and rest you uh, do it on a do it from the scratch, so that you can have the practice as well. So on the R16, which is Australian router, I configured a name. I configured IP address on the interface. Let's say it's Australia R16, and let's save this. Copy, run, start. Okay, fine. Let's go to Japan's, and let's start with the actual VPN configuration. So we are first going with phase 1 configuration. Phase 1, I told you there are parameters that we need to configure in the case of phase 1. So what are the parameters that's required? I need something for encryption. I need for authentication. I need Diffie-Hellman group. Okay. And I need a ICKMP policy number. Okay. So this is my policy number, and beneath the policy number, I have the parameter that is required for ICKMP. So it's MD5 encryption. I have my pre-shared key because I want my phase 1 to be negotiated on based of pre-shared key, not based on certificate. Okay. So remember that. So I opted for pre-shared key, not for certificate. I went with group. Are we good now? Actually, there was a issue with my ISP, so I have changed it now. It should be all right now. So let's wait for 1 to 2 seconds so that network get stabilized. Okay, so looks like it has normalized now. Okay, so let me tell you, I'll let me go back to like 10 to 20 second. What was I discussing? So we are first going with, or we are first configuring the phase 1 configurations. So for phase 1, we need the ICKMP policy number, and rest of the parameter will be beneath the policy. Okay, so we need to define encryption, which is this. uh, this is encryption. Okay, we need authentication to be defined, which is nothing but this. We need to define what is my secret key would be. Is it a PSK, or like is it a security key, or it's going to be certificate? So I have selected pre-shared key, not the certificate. Okay, and then I'm also going to define my Diffie-Hellman group, which is nothing but which provides the strength, or which provides a key for every particular session. Okay, so what happens is, let's say if my data packet is in a sequence, if someone try to hack 3 packets, okay, there's still hope that he can crack the rest of things, or he can crack what are the information based on the 3 packet. But what this DH does is, they create a separate key for each one of them, so it becomes very difficult for someone to try to decode or decrypt those packets, because key is not same on the complete sequence. So it's going to keep a different key for different sessions. So these are the phase 1 parameters. Okay, so let's configure that. Let's put up on the first router, that is Japan router. All good. Now we need a loopback interface which can have. So let's say this is my router which I have over on my GNS, which is Japan. Okay, and I have Australia, right? So where is my IPsec tunnel been establishing? So basically I have to define these two IPs. So this is 12.1.1.1 and this is 12.1.1.2, right? There could be different tunnels as well. So this is one tunnel, this is one tunnel. So, but I'm right now focusing on this tunnel. So I have to set the IP address. So let's say it's crypto ICKMP key. Okay, what's the key that you want to define? So let's say it's Cisco, and what is the address, where exactly is this tunnel being built? So it's over on this. So this is the destination IP 12.1.1.1. Okay, so phase 1 configuration is done. Now let's focus on phase 2. So for phase 2 we need to have transform set. So what is this transform set carrying the information? If you try to see here, this is the name of that transform set. We call it as transform set. What does it carry? It carries two information, that's nothing but encryption and authentication. Okay, so basically for phase 2 also I have told you it need couple of information. It need encryption, it need lifetime, it need authentication, it need the tunnel mode. So let's say in phase 1 it's going to need like 4 to 5 parameters, and in phase 2 it will ask for like 5 to 7 parameters. Okay, so this is transform set. That's for encryption and authentication for the phase 2 parameters that's required. Okay, once we have defined those things, we are just defined, we have not called it. So let's go with next command. Next command is about allowing the interesting traffic. Now what is interesting traffic? So let's say this is Australia and this is Japan, right? So let's say we have configured the VPN on both the end, but how are you generating the traffic? Or let's say what is the actual traffic that would be sent over on this tunnel, right? So we call those traffic as interesting traffic. So let's say on this LAN segment, this is one network which is the interesting traffic. So we will make use of the access list. Okay, extended type access list. Similar thing over here. What is that traffic that has to be sent or would be communicated? Okay, ACL. So we need access list on both the sides. So this access list is for this particular VPN. So every VPN can have their own access list. So what are you trying to allow here? So in shortcut, or let's say I have Australia, I have Japan. So behind Japan router there is 1.1.1.1, which is the LAN network, local area network, and behind Australia there is 2.2.2, which is the local area network. So basically this user wants to communicate to this users over on this tunnel. So we are defining the interesting traffic. So let's say access list 100 permit IP host 1.1.1 source is 1.1.1 and destination is 2.2.2. Okay, so once you done that, now we will go with the parameter configuration, because we have not configured parameter so far. So this was parameter for phase 1. Okay, this is also phase 1. So under IPSec we just did two things so far. One is transform set. We have not still called it, we just defined with this word and we just kept it. It's just lying there so far, we have not called it. Similar thing with access list. We have defined access list but we have not called it. Now we will define all the IPSec parameters. What are different IPSec parameters? Okay, so this is my IPSec parameter. So what does it say? So we are talking about the destination IP. What is the tunnel destination IP? This is nothing but my access list, interesting traffic. This is my transform set. Okay, so all the parameter within the crypto map. So for IPSec definition or IPSec, to define IPSec, we make use of crypto map, and this crypto map will be later on called up on that interface. What is this interface? This is the outside interface. Okay, so if I have two routers, so this is that outside interface where my crypto map is being called. So basically, what is that crypto map carrying? It's carrying the destination IP, it's carrying the extended access list, is carrying the transform set. Okay, so this is whole together dependent. So these are the few lines which are dependent to one each other. So this is your outside interface, and you are calling the crypto map called as TST, and that TST is nothing but you're defining whatever the parameters. Okay, so let's copy this. Okay, and let's this would be your last line for VPN. So we have called it, we have called this. So you can see that ICKMP is on, all those things, because things are being configured in a right way. Now I need a static route here so that I can do some testing, or I can try to send some packet and my tunnel gets triggered up, because if tunnel is not getting triggered, then I cannot test if whatever I did is right or wrong. So I will make a static route entry. So what is my static route entry? So basically, let's say this is the loop back, which is 1.1.1, and here the loop back is 2.2.2. So I'll just set static IP over here saying that this traffic should take this path, and similar way I'll set a static route here saying that traffic towards 1.1.1 should go this path. Now what happens is, immediately the first packet takes that path, your VPN start negotiating. The phase 1 negotiate first, then the phase 2 try to negotiate. That's the whole purpose, right? To so that we can test. Otherwise I could say that I have done the configuration and we are good with that, but who is going to test it, right? So if I do show crypto ICKMP SA detail, so you see the VPN is been set up, but it's not up. So for that reason I will put the static route so that we can test. Okay, what about my loopback address? Do I have any loopback address right now? So let's see that as well. So I don't have any loopback, so let's create that. Okay, what about the second side configuration? So let's copy the entire thing, which is very similar with what we did so far. I'll go to the second router and I'll just paste it, the entire thing. Okay, so we are done with VPN, we are done with loopback configuration, we have done with static routes, which is required for this testing. Let's create some debugs. Okay, so I can show you. So we will not enable debug throughout on this router, but we will enable the debug just for this tunnel, because in a production, don't go and enable debug for a global VPN. Might be you have thousands of VPN, and every VPN will start accumulating the packet, so that's not a good idea. Okay, so we say debug crypto condition peer. What is peer? From Australia router point of view, who is peer? Peer is this. Okay, so now what happens? Only this VPN information is something which we would get it. Okay, so debug crypto condition. Okay, peer. .1.1. Okay, so let's define the IP address, which is 12.1.1. Let's also enable debug for phase 1 and phase 2, which is called as debug crypto ICKMP, and let's give some level. Okay, this is a router, that's why the commands are a little bit different. In case of Cisco ASA firewall, the commands was just peer and the peer IP. This is a router, so we are adding one extra keyword. Similar way in the case of ICKMP, let's go with error. I guess that should collect everything. Let's go with debug crypto IPSec. Let's go with states, or let's go with messages. Okay, fine. Okay, let's try this. Okay, so as of now, there's nothing which is up here. Okay, we need to generate some traffic. So for generating some traffic, I can just give a ping test. Okay, and we can see what happens. I also have my Wireshark, which will show us if we are able to generate the traffic or not. Okay, so let's ping. Okay, so it's reachable. Let's see from tunnel point of view. So the tunnel is up. Okay, so we can see the tunnel has come up. Active, encryption, hash value, authentication, DH value, lifetime. Okay, what about IPSec? Show crypto IPSec SA peer 12.1.1.1. So it's up as well. So it says active. Okay, the IPSec will contain lot of datas or lot of values. I would always say that make use of filter. So the required thing here is encryption and decryption packet, and you can go with PKT. Okay, so you see that there are the IPSec is up, but the traffic is showing 0 0. Okay, let's try to put the source to be loopback 0. Let's try to see the traffic counters, and now you see the traffic increased. Okay, the reason is you're having your interesting traffic now. So when you say loopback 0, so basically what it does is you're setting the right traffic. So let's say this is R1 and this is R2. This is 1.1.1.1 and over here 2.2.2.2, and this is the interesting traffic that you have allowed over here on this tunnel. So when you say ping this IP on basis of this as a source, so this is source and this is destination, that's the actual traffic that gets counted in your IPSec VPN, because that's your access list which you defined in that way. If you don't add this source, now what is it happening? You're still able to ping, but source is now this IP, the physical IP address, and that is not the actual traffic that is defined in access list. Okay, it is still working because you have that static route. That's why they are reachable. But the interesting traffic is this and this, from 1.1.1 to 2.2.2. It's not from 12.1.1 to 2.2.2. Okay, so that's two things here. When you ping without giving the source, it would have considered this as a source. So we are strictly defining that my source is this. As soon as we did that, we can see the counters are increasing. Okay, so I can check it out. So we see ncaps and decaps. Now what is actually happening here? So that says your 10 traffics were sent over on the tunnel, and on the other side that those 10 packets were decrypted. Okay, so let's say my packet number 1, 2, 3, so on till 10 went within this tunnel, which got encrypted using IPSec encryption method, and over here those packet 1, 2, 3, they got decrypted. Okay, so you can see that N caps and D caps. So you sent 10 packets, you received 10 packet. Now this is one of major factor for troubleshooting also, because we see sometimes when the VPN is up on both the side, but still users are complaining that the traffic is not actually reaching towards 2.2 network. The reason could be there is some routing issue over in the LAN part of the other side. Okay, so how do you narrow down such scenarios? When you try to ping, you can see the encaps will be increasing. Encaps will be increasing to 10, 20, 30, and they are gradually increasing. But on the other side, okay, the wherever the issue is, so you will see, so you, if you see my output, you see two things here. You see in ncaps and dcaps, right? Now let me tell you what exactly is ncap. Ncap is your own traffic, which is whatever it is. Let's say it is 10. When you see dcaps to be 0, in such scenario, that means the return traffic is not coming back. Okay, or I can say in this way, if this is n caps equals to 10, that means the same traffic over here is for d caps equals to 10. Okay, so you are encapsulating 10 and decapsulating 10. But in the same time, when there is a traffic which is coming, or the return traffic, now if the encaps will be 0 here, and those traffic over here will be shown in terms of decaps equals to 0. Okay, so that is a fundamental between this encaps and decaps. So take it as this way, that encap is one side and decaps for those same traffic is something which is on the other side. Okay, so you will see most of the time whenever you're troubleshooting, you will see encaps are increasing but decaps are showing to be 0. So don't conclude the VPN is good, because there could be reason that on the second side there is routing issue, so your traffic is not hitting those destination. So if there is no reachability, or if the packet is not hitting the destination, that means there is no return traffic coming back. So your VPN tunnel is just counting one sided traffic only, and that's why it is increasing the ncaps. Okay, now what is decap? Decap is nothing but on the other side, right, which is not happening, which is not increasing. That means there could be issue on the decap side, on the receiving side. So there are a lot of troubleshooting factors which we see in case of VPNs, especially site to site VPN. So as of now, we are all good with this VPN. I'll once again show you both the phases. So this is my first phase, which shows the VPN is up and running fine. This is the encryption. This is the authentication. This is the PSK method which we are using. This is the Diffie-Hellman group. Okay. And how do we check the phase 2? So I can go with filter, which is a wise advice, or it's a wise idea to make use of filters. Okay, and you can see you sent 10 packet on router 1, and those 10 packet were easily decapsulated on the router 2. So for your 10 packet you have 10 response back, so that's a good thing. Okay, you will see sometimes when ncaps is 20 but decaps are 10, that means the 10 traffic were lost, might be due to some routing issue on the second side, or might be your VPN was not built initially. So the counters should be very same on the ncaps and decaps should be same. It's like your ping packet, you sent some packet but you didn't receive some response back. Now you will you will get some packet drop or slowness, right? So VPN is also same thing, you're sending 10 packet, so that's one side, source to destination. Similar way, the destination to source will also have to come back if it is a bidirectional traffic. Okay, but yes, on the second side, if it is a banking sector, they might block those traffic, they might block the return traffic. In that case, decaps will be still shown as 0. Okay, so that's why I said it depends on the requirement. So if they are a normal customer, they will not put any restrictions for decaps. So whatever you send, there will be a return back traffic. So ncaps and decaps will go like next to next. But if they put some command so that uh, it's just a one sided VPN, that is from site A to site B, but not site B to site A, so in that case ncaps will be shown as increasing, but decaps will be shown as 0 itself. But they will test it and they will say that we are good, we can access the server, and we are good with the tunnel. Okay, so it depends upon the two parties or two network administrator, one from site A and the other engineer from site B. They will set up the call, webex call or something. They will do the live testing. So they will push some packet, and they will just do this two commands, and they will say that okay, everything is fine and everything is working. Okay, there is one more command which is running on ASA firewall, but let me check on router. Okay, I guess we don't have that command here. So we have a command which shows the VPN uptime. Okay, it's called as VPN session. Okay, so we don't have that command on routers. It's a ASA command where we can see something like this. Okay, so when I put this command, I can see what is my uptime of VPN, for how long my VPN was up and running good. All right, so this was IPSec details or IPSec tunnel. So we have configured, we have done validation, we have seen some troubleshooting scenarios. Okay, okay, regarding packet captures, so we can do that. So let me initiate some ping traffic. Okay, so this has been changed now. So it will not capture for, so let me apply capture here. So we can see the VPN traffic. Okay, so I told you, so we have two protocols in the case of IPSec. We make use of ESP or AH. So AH is a little less secure, and it is faster, and we don't use it for site to site. It is most widely used for remote access. Whereas ESP, encapsulation security payload, this is authentication header, which is widely used in remote access. This is encapsulation security payload, which is used in site to site purpose. Okay, so by default, once you configure the site to site VPN, so this is something which is by default getting enabled. If you need AH, then you have to put a command saying that I need the mode or the protocol to be AH. Otherwise, by default, ESP will take up. So that's why you see the protocol is ESP. So my traffic between the two site, Japan and Australia, the ping packet which I just tested, they are actually taken over IPsec. Okay, so you can see what is encapsulation happening. So this is the IPsec traffic. Okay, so which traffic from Japan to Australia. So that's a ESP protocol or encryption. Okay, now let's also see what is GRE tunnel, which is again a part of NCore and NRC. Okay, so GRE versus IPsec. Okay, GRE being one of the oldest VPN technology, but nowadays we don't use it much. There are two drawbacks. One is they don't provide security, and the second drawback is the header size of GRE will consume like additional 4 bytes. Okay. So if you see from IPSec point of view, it's going to provide you security as well as the header is very small. So if header is small, that means the data will be higher. But in GRE, it's different case. Header itself is larger and you can just add a very small portion of data. So let's say you had to send 10 packets, might be IPsec takes 10 packets. The same thing if you make use of GRE might would have taken 30 packets. So the packets are increasing because the header is increasing, packet is getting shrinked. So you need more number of packets to uh, forward the whole data, right? So that is the two drawback. So let's see from the table point of view. Okay, so what is GRE? It's a generic routing encapsulation. IPsec, it's IP security. Okay, uh, what is the purpose of GRE? It's a protocol that will encapsulate packet in order to route over IP networks. Whereas what is IP security? It's a standard based mechanism providing privacy, integrity, authenticity for to send those packets from one side to other side. Okay, so always remember IPsec provides three best or the three advantage, that is integrity, authenticity and privacy. Okay, so this is a CCNA security topic which I remember from my previous batch where I used to discuss what is integrity, authenticity, and privacy. Okay, it's also uh, there was a model which we used to call it in CCNA security. Okay, it was called as CIA model: confidentiality, integrity, and authenticity. Okay, so something like, say for example, this is user. Okay, if he's making a banking transaction, okay, what is he expected? He is expected to put his username and password, right? And then he is eligible to access his account. Does the second user, if he don't have that same username and password, do you think he will just put some user and name and he can see someone else credentials or someone else balance? So basically to see a balance he need a username and password, right? So that's a confidentiality. So if you have your own credentials, then you are the rightful person to see the balance of your own account, right? So to see a different person's account, or if someone wants to see your account, either you have to give them the credentials or the confidential matters and then they will, otherwise they are not being asked for, right? So that's a confidential. What is integrity? Integrity is something, if let's say if one is making some transaction, okay, so basically do you think that he, if he is trying to send $3, okay, will he be allowed to do some kind of data manipulation and say that he sent $5? Does it make sense? So basically integrity is something which deals with uh, the rightful owner. So in this case neither the user, neither the bank people are really the rightful person to do any changes with the transaction that a user is performing. Okay, so it's integrity. And authenticity is nothing but just with your uh, data security. Okay, so that the data are not being manipulated. So this was a small topic in CCNA security. So basically these are some features which IPsec VPNs provide. Okay, so that's something which is mentioned here. Where do we use GRE? If we we already know that there were two drawback which compared to IPsec. So why do you think GRE was used? So in case of GRE and IPsec, there is very big difference. That is, GRE will support lot of different packets. Okay, for example, it's going to support uh, so where is it? Okay, so if you see here, GRE will support multicast routing protocol, which is your EIGRP, BGP, OSPF, and also routed protocol. Routed protocols are your IPv4, IPv6, Apple Talk. So that's the advantage of GRE. But in the case of IPsec, they just support unicast only. It's a unicast supporting mechanism. Okay. What else? So in the case of encapsulation, it's encapsulating the payload, whereas in IPsec we have two ways, where the tunnel mode is going to encapsulate entire packet, whereas transport is just payload. Okay, something you can compare transport with GRE, but by default this is getting enabled. So in my case, when I just configured between two sites, by default tunnel mode was set up. Okay, it's providing the entire packet and encapsulated. Privacy, integrity, and authenticity not supported. Mode, it's just a single mode, whereas in IPsec we have tunnel mode and transport mode. So we know what is happening in tunnel and transport. From the standardization, so GRE is being defined in RFC 2768, whereas IPsec is defined under this RFC. Okay. Port number, protocol and port number. So it used the IP protocol 47, whereas here the IKE version 1 or ICKMP, it works on UDP 500, and ESP or AH, which is part of IPsec, they work on IP protocol 50 for ESP, and for AH it is 51. Okay, so this is another change between GRE and IPsec. I don't say it has changed, I can say that that's how they work. Okay, so GRE works on protocol number 47, and for IPsec, since there are two phases, phase 1 takes UDP 500 and phase 2 takes this protocol number. Regarding the IP header, which I told, it is going to consume 4 additional size for IP header, whereas IPsec will not consume any additional. So remember this conversion, 1 byte equals to 8 bits. So 4 byte is going to take like 32 bit, right? So a lot of space is just wasted in sending the header in case of GRE. So from support point of view, they are supporting multicast, routing protocol and routed protocol, whereas IPsec only supports unicast. They are not supporting the other mechanism. Regarding configuration, GRE is very simplest. Okay, whereas IPsec is little complex because you have lot of parameters, you have two phases, there are couple of messages, right, which you need to know from interview point of view as well as from theoretical point of view, because in IPsec there is lot of room for questions, but in GRE it is very simple. I'm going to do the GRE lab as well, so you will realize that yes, it is very simplest option. Okay, these are the example for routed protocol. This is an example for routing protocol. Okay, so we use GRE, but we use IPsec to provide security, because you know GRE doesn't have security, right? So we make use of IPsec encapsulation to give security features to GRE tunnel. Okay, if this is a GRE tunnel, we add the encapsulation of IPsec to, so that you are having a simplified option of the tunnel as well as you have the security features on the GRE. Okay, regarding the configuration, we are considering the same two site which we used for IPSec. So this is my site number 1 and this is my site number 2. So I'll configure GRE between these two sites. Okay. So let me reload the router once again. It will take like 5 to 10 seconds to come up with a blank configuration or a default configuration. And then we are good to paste this. Okay, so meanwhile let me tell you what are the configurations. So I'm just configuring interface and loopback. Okay, loopback I need for testing this GRE. What about interface? Interface is nothing but that's the public interface. Okay, and loopback is here, which I need for testing the GRE or to bring up the GRE. Okay, this is the GRE configuration. I create a tunnel, a virtual tunnel will be enabled. I set a IP address on this and then I define the source and destination. So this will act as source and this will act as destination from this router point of view. Remember, okay? And then I'll configure a static route. So static route is nothing but I'm forcing my traffic, I'm forcing my LAN traffic to take that tunnel which is being defined, tunnel number 0 in my case. So I'm saying this traffic should take the tunnel because there could be some other breakout. Might be there is some other breakout to go towards internet, right? I don't want to happen that. So I put that static route. I say to reach 2.2.2.2 take the tunnel. Tunnel is over here. So the moment traffic will hit this tunnel, my GRE should come up. So that's how I'm going to test it. Okay. So let's hope the device is up. It's up now. So let's see what are the IP addresses that's up and running. So we don't have loopback. I'll do that. And from here, this router point of view. Okay, so we are going to add interface first. Okay, so I'll also save this because these are some configuration which is used every time. So let's do copy run start. And same thing on the second side, interface with the loopback, which is something which we do it and we know how do we create. So no point doing it every time and wasting time. Okay. What about my GRE configuration? My GRE configuration is just plain 4 to 5 lines. It's about configuring tunnel, the tunnel IP. Source is my own outside interface or the physical interface. Destination is nothing but the other or the peer router's physical interface. I make this tunnel as no shutdown. Okay, so let's do that first. So this is my first side of configuration. Once I've done that, I'm forcing my LAN traffic to take this tunnel now because as I told you, there could be other breakout. Let's say if there was another interface here which is connecting to ISP2. Now my LAN traffic would have taken that traffic. So how do you think my GRE will come up and how do I test it? So I'm forcing it by writing a static rule. Okay, a static routing. So I say that my 2.2. On the other side will take the tunnel always. Fine, we are good from one side of configuration. So from second router point of view, once again I define tunnel, I set the IP, I set the source and destination. So now the source and destination is being changed. Okay, so earlier this was .1 and this was .2. I had said that source is .1 and destination is .2. Now since I'm working out on the router 2 configuration, the source becomes .2 and destination becomes .1. So that's why you see .1 and .2. This is source, this is destination, source and destination. So let's copy this. Okay, so this is my second configuration. Okay, and as usual, I'm forcing the this local area network traffic to enter the tunnel. Fine. Let's see if the tunnel is up or not. So let's go with show interface tunnel 0. I can see the interface is been created. Okay, so tunnel is up, line protocol is up. That's the first thing which I have to see, which is good. Okay, what about traffic? I don't see any traffic at the moment. So the traffic shows 0 and 0. What about rest? So there is no input traffic and there is no uh, outgoing traffic. Okay, not error, this one. So it would be good that I put some filters so that I don't waste time on checking every line. So we can go with this command. So tunnel is up and up, line protocol is up and up, traffic is 0. So to test this, we can force those traffic to take or to initialize. Okay, so I say that ping 2.2.2, consider loopback as my source because I don't want the physical IP get counted, and let's repeat that so that I have lot of traffic. Okay, so it is reachable. That's a good thing. Now let's try to see the tunnel. So let's say show interface tunnel 0 line and packets. So we can see the traffic is happening. Okay, so we can see the traffic is happening over on tunnel interface. So that means my GRE has come up, right? So tunnel is up. Let's see the same thing from Wireshark point of view. So let me filter it for GRE. When I do it for GRE, I can see the packet has been captured. Okay, for my recent traffic, I can go and check one of them. So we see the GRE header is being added up to this traffic. So this is 12.1.2 to 12.1.1.1. We can see the GRE header has been added up. Okay, so we are good with this. So my traffic now between these two sites are sent over GRE tunnel. So we have a successful GRE tunnel. I am running the Wireshark capture here and I can see the packet is communicating with a GRE header. Okay, configuration wise, simplest option, but GRE is not going to give security, and the second drawback is it is having very large header size. Okay, so we usually go with GRE plus IPSec in such scenarios. Okay, but since it's again the same drawback of having lot of header, so the best option when we have two site is to go with IPSec site to site connection. That makes more sense. Alright, so that ends your class for the day. I will quickly open up the PDF or the syllabus blueprint. Let's see where we stand and what are we left with. So we have covered a lot of things in the previous week. From automation, we just completed the entire thing. So I guess there's another 10 days of class which is required. Okay, so let's quickly mark what all things we have completed. So we completed GRE and IPSec today. So we have completed these things. Debugs, conditional, debugs, traceroute, SNMP. SNMP is not completed. I'll take that. We have completed NetFlow. We have completed spans. We have completed IPSLA. We have completed NetConf and RESTConf. We have completed REST API security, and automation is all completed in the last week. Okay, so this is from Encore point of view. So we left with some theoretical point from a theoretical topic, WLAN, SD-WAN 1 class, QS 1 or 2 class. This is one class along with some other topic. Same thing with Lisp and VXLAN, which is already covered in SD Access. But I'll give few more points with few more chart and all those things so that you know what is happening. Once again, this is all wireless topic, all described. So might be wireless is like 2 to 3 classes for us. Okay. And yes, once again, some small portion for describing the component. So let me save this. What about NRC? Let's highlight the completed ones. So I have okay, so I have IPSec done. I have done GRE. So this has been completed. IPSLA completed. NetFlow done. DNA center is being done on the first day while discussing the SD access, but it was not marked. Okay, so this is Cisco DNA center. So over here might be 1-2 class for VRF and BFT and the policy routing and these VPN. So DM VPN is with lab, okay, theory plus lab. As I told you, MPLS is just about describe, it's no configuration. So we will see how much we can cover from the MPLS point of view. We have IP6 traffic filter and IP6 IPv6 first hop. So basically one class for IPv6, the IP the IP classes, what are the different mode, because in IPv4 we have broadcast, multicast, unicast. In case of IPv6 we don't have broadcast, we have multicast, unicast and link local. Okay, we will also see the different classes like in case of IPv4 we have class A, class B, class C, DE, right? In similar way IPv6 also have some different types of uh, representing this IPv6 IPs. So we will see if you see something like FE, so what is it example for? So we have some topic for that. Okay, and then SNMP, which is also a repeated topic in the case of ENCODE, and that ends your whole CCNP. So I guess might be 10 days, but yes, 10 days of the current coverage, we are just taking like 2 to 3 classes every week. So 10 classes if you just spread it out, so might be 2 weeks to 3 weeks. Okay, I'll try to cover it by this month end so that you guys can commit your time on something else for might be writing the certification or for practicing, or might be you guys are already engaged with some other course by now, right? So we will not take it or we will not stretch it for next month. My plans are to just complete it by end of this. So we need 10 classes. So we have like 4 classes here and 4 class, and might be we have to go with first week of September. So that will end this whole batch. Okay, fine. So let me know if you have any questions from the GRE and the IPSec topic, the topic that we discussed today. Okay, so I told you already, when you see this decap 0, there could be 2 answers for that. So when you have ncaps getting increased, but at the same time the decaps are 0, there are 2 reasons for this. One is, let's say if your company name is XYZ, okay, you're providing some software to a banking sector, they are a huge banking sector. So basically you will set a VPN tunnel between these two. So let's say if the banking guys are always accessing this, okay, but at the same time they don't need your traffic to come back to them, they just need it to be one sided or only one direction. Okay, so what they are going to do is they are going to block all the traffic that you are trying to send. So this is just going to be one sided traffic. Now what happens in such scenario is the ncaps will be shown up as increasing because they are accessing our traffic, but dcaps will be shown as 0. So don't take it as that VPN is down or VPN is not working. That could be reason when they have blocked the traffic. Okay, that is one scenario. Second scenario could be a troubleshooting case. That is when the configuration from their VPN terminals towards their internal LAN segment is having some issue. Might be the routing is not good. So what is happening is your ncaps are going. So traffic is going one sided. Okay, it is going till their router, but the router doesn't know how to reach to the destination. So in this case, what happens? The traffic is going there, but it's not getting decapsulated, or they are not getting decapsulated, or not trying to uh, go towards the destination. So in that case also you will see ncaps is increasing. That is good from your side, but from their side decaps is not happening. So in such scenario you will tell the remote engineer that I can see my traffic is entering the VPN tunnel, but on your side decaps is still showing 0. So you have to see your internal routing. Might be that is an issue on your side, or check or try to run the debugs. Okay, try to run the debug and see if the traffic is coming back. It's not an issue with the VPN, because if the VPN had a mismatch, then IPSec will not come up. Okay, so IPSec is up in this case, but only ncaps are increasing. The dcaps are not increasing, right? Dcaps is their traffic. So that's the traffic when the return packet is, when the return packet hits back. So that's not happening. So that could be issue with their internal routing. So they will take care of their internal routing. Okay, so two things can be possible. One is they purposefully blocked it, or might be the internal routing is not very good, so traffic is not hitting the destination. Okay. Virtualization is very small topic. It's, yes, it's VM EXI. Okay, and it's not about vendor specific. It's about the type 1 and type 2 VM or virtualization that we are going to discuss. So I'm going to discuss like which kind of virtualization we call it as type 1. What are few examples of that, and similarly what are type 2 and what are some examples of that. So they are like multi vendors virtualization would be considered, and I'll tell you what is what and what is what. Okay. All right, guys. So I guess it's all good from all of you, and let's meet up in the next class. I'll pass on the document and all the lab material so you guys can practice during weekend. So let me see what is a chat window. Okay, fine. All right, guys. So thank you for joining, and see you soon. Okay. So see you soon in the next class. Have a nice day.